Greetings, I'm Squared, and we are going to talk about compounding interest continuously. And there's a special little formula for that. It uses the number E, and we call it PERT because you see the P-E-R-T, so that's a good way to remember it is PERT. So it's important to know what each of these letters represent. A is the amount you have after T years, and they'll either give you T or you'll be solving for T. So it's the ending amount. P is called the principal amount. It's the amount that you originally would have invested in the account. E is, of course, the number E, which is approximately equal to 2.71. R is the interest rate, so that's not a percent, it's a rate, so you have to change your percent to a decimal. And T is the number of years that you are investing the P amount of money. So our example here is John deposits $2,000 in an account that pays 3.75% interest compounded continuously. The first question is, how much money will John have in 5 years? Well, so this is our T, this is our P, this is our R percent. It's not our rate, it's our percentage rate. So we have to write an equation and solve for A because they want to know how much money he'll have at the end. That's A. So A equals 2,000, which is our principal or starting amount, times E to the rate. Now, I don't know if you remember how to change a percentage to a rate, but you just divide by 100, or remember when you divide by 100, you're moving the decimal place to the left twice. So that's our rate, and then times T, and our T in this case is 5. So the only way to do this is with a calculator. So we take 2,000. We times it by E. Hopefully your calculator has a little ln key, and on the second function of my calculator has a little e to the x key. And you take that e to the x, and we're going to put 0.0375 times 5 inside that parenthesis, because all of that means the exponent. It's really important that you do that. If you end the parenthesis and then say times 5, it's multiplying this whole thing times 5. And you'll know, if you think about it, you'll get something outrageous, because we don't expect at 3.75%, we don't expect tons, maybe several $1,000s in 5 years. We don't expect to double. And if you multiplied the whole thing by 5, it would definitely double. So we get 2,000. Well, it wasn't a couple thousand, it was a couple hundred, if you had 400. 2412.46, and it's money, so we round to the nearest hundreds, 46 cents. So this is the amount after 5 years. Well, it asks how long it will take John to double his money. Well, first of all, if we know that in 5 years it only went up $400, we could guess and say, I don't know, around 20 or something like that. So what we're going to do is we're going to come back and we're going to put in all the information we know. Well, we know we started with 2,000. So we know doubling would have to be 4,000. And I'll show you a shortcut that some people use when you're doubling. And then the rate stayed the same. And we're solving for T. We don't know how many years it took. So that's our variable. So we're going to have to use logs to solve this equation. But we have to get rid of this 2,000 first. Since it's being multiplied by E, we're going to divide by E. So we get 4,000 divided by 2,000, which is 2, E to the 0.0375t. And here's where I'll share the shortcut. Some people just say, well, if I know it's doubled, then there's like a 1 there and a 2 there. And so they skip this step. They just put 2 equals E to the rate times T. And if it was tripled, you could say 3 equals E to the interest rate times the time. So it's a little shortcut if you so desire. Well, how do we solve an equation? When there's a variable in the exponent, we use logs. Since we have an E, we use the natural log. So we ln both sides. So we get the ln of 2. And the ln and the E cancel out. That's the whole reason we do it. Hopefully you remember that rule. So now it's just a linear equation. We solve both sides by 0.0375. And let's see, we estimated it to be around 20. Let's see how far off we are. Divided by 0.0375. And it's 18.5 18.5. We'll round it since it's talking about years and not money. We know that it's going to take about 18.5 years. We were close. Okay, so the last part of this is what interest rate would John need in order for him to double his money in 10 years? Notice the first time we solved for the amount, the second time we solved for time, and now we're going to solve for the rate. Again, the rate is in the exponent, so we're going to have to use logs. So what interest rate? We still do the double, so let's do the shortcut this time. If we know it's going to double, it's going to go from 1 to 2, so we'll just put a 2 there. E, we don't know the interest rate, so we use an X there. Oh, we should use an R, I suppose, to keep it nice and pretty. And 10, so times 10. So when I rewrite that, I'll write 10R. So again, when we are solving for a variable in the exponent, we use logs, and since we have an E, we use the natural log. So we say ln2 equals 10R. So we divide both sides by 10 to solve for R, and R equals ln2 divided by 10. And we get 0.0693, we'll say. And if we wanted to find the percent, we'd move that over 2 times to the right or multiply by 100, so we're getting 6.93%. So it's almost 7% is what John would have to have in order to double his money in 10 years. And this is how you compound continuously. If it does not say continuously, you have to use another formula. So keep that in mind. And this is M Squared, signing out.